Hello, today we continue to talking about the part. Okay, part. So before we're talking about if you have the power function or power, usually set the u. But in this case, exponent, cosine, and trigonometric function is not. But how we can set up here? In a different way. But method is the same, but not simply. Because if u will be something going to be 0. We set up the u, but in this case it's not. Exponent, cosine, or trigonometric, like a repeat function, so it's not. So let me show you in this case how we can set up. So let u will be like exponent ex, and dv will be cosine x dx. Okay, so du will be same to exponent, which means ex dx. And how about here the v? So cosine integral will be sine x. Okay, so this one integral, one more time, integral ex cosine x dx equal to uv, which means ex sine x, subtract integral ex sine x dx. Also, it's not going to be 0, so not constant number. So ex sine, right? I kind of repeat one more time. U same ex, which means du also ex dx. Okay, how about dv sine x dx is going to be integral v will be negative cosine x. Okay, so here ex sine x subtract negative, and ex times negative cosine, negative here, so this is positive ex cosine x, and negative and cosine negative and actual negative, so 3 negatives keep negative, and integral ex cosine x dx. And can you see that? Let me change the color. I'm showing something like this number, this function integral, this integral actually same. So this one shifting to the left, and then write down the color. So 2 ex integral ex cosine x dx, and here ex sine x plus cosine x plus c. Okay, and then divide 2, this one divide 2, right? So finally our question ex cosine x dx will be ex over 2 parenthesis sine x plus cosine x plus c. Okay, that's our final answer right there. Okay, can you see that? So repeat, we're gonna using the characterize, so should be come out like that. Okay, right, next problem. So tabular integration, so when they use, if they have like that kind of similar problem, what many repetition, so repeat required. So calculation is cumbersome, too too heavy, right? So that time we using tabular integration is way to organize calculation, save rate to deal the work. So something repeat again. That time using this method. So for example, so here I think you saw before. So usually x squared going to be u, right? Oh, let me change the color. It's hard to see that, right? So maybe this one. Okay, this one we usually using u, right? This part dv, right? So if you want, you can do that. So x squared means going to be x squared 2x going to be 2, right? Going to be 0. So we need 2 times. So trying to make a table easy to look at. So how look at that? First of all, first part fx, which means u part, gx here like v part, to make the table. So when you derivative fx, x squared 2x 2 and 0. How about integral ex? But integral is the same, exponent always same. Okay. So how can I find the answer without doing part using the table, right? Tabular integration way. So first of all, that one and second one. So first one, because we didn't, when you do remember this one, we have u dv, first part uv, which means u just come out, right? So that's why here first one and second one v, integral for that one, right? So integral for ex, integral. So that's why here's the derivative part, this is integral part, okay? And this one make this positive, right? This positive. The second one, do like subtract, right? So v du, anyway, the subtract and take turn like this way. So how can I find the final answer? Like this way. First one, x squared ex and minus sign, and 2x times ex plus sign, 2 times ex plus c, right? Alright, same thing, try other one. It's this time like cube and sine, cosine, exponent, actually same method. So first of all, first part what? U, second part v, right? I mentioned that. So u part for like in derivative, and v part for integral, derivative integral. So x cubed derivative 3x squared 6x and 6 and 0. How about integral? Sine x integral minus cosine x, minus cosine x minus sine x, and cosine sine, like that. So we matching that first one, third one. First one, second one, third one, like that. Sine plus from plus 2 minus, take a turn, right? So here plus and second, third minus, and third, fourth plus, and so on. So only write down here. So how can I do the answer? Take turn. Plus, which one's cosine x cubed, and next one 3x squared minus sine x, make positive, and 6x cosine negative, and plus here that way. Alright, keep doing that. So after that, you can using tabular integration is much easier using table. Okay. Alright, other one. ln x. So looks like 1. We gonna using also part method. Okay. So let's say imagine that looks like ln times 1, which means u will be ln x, dv will be just 1 times dx, simply, right? So here why we're gonna using du will be 1 over x dx, which one, this derivative will be v will be x. This number and that number make it cancel because just constant number, right? Alright, we try. So uv will be x ln x, and subtract x times 1 of x, 1, right? So 1 like dx, you don't have to write that 1. So here x ln x minus x plus c. This principle, right? Alright, next one, last question. So alright, so solution for differential equation. So which means we should find general solution, and using condition, initial condition, we find particular solution and the graph. Okay, so first of all, here dy dx sin x, we change it to, how we can change sin x dx, this one change it to what? Y integral inverse sine x dx, right? So this one, how we can do that? Same way, using part. So u will be inverse sine x, dv will be just dx. This is an easy one because v will be x. Do you remember derivative for sine inverse x? You can look in the book. So du 1 over square root 1 minus x squared dx. Okay, so how we can do that? Y uv, which is x, sine inverse x, subtract integral x square root 1 minus x squared dx. Okay, method part 1, right, this way. So we're gonna do 2 using substitution rate. So 2, which means u denominator part 1 minus x squared, du will be negative 2x dx. Okay, and divide the negative 1 over negative 2, which means du 1 over 2 x dx. Because the numerator we have only x part, that's why we're gonna change that this way. So write down one more time. So first part the same, x inverse sine x, and negative 1 over 2, so make positive 1 over 2, and this part change it to u and square root, so simply u negative 1 over 2 du, right? Here x sine inverse x, and plus this one plus 1 over 2 is upside down, so which means only left u 1 over 2 plus c. Okay, now final part, x inverse sine x plus square root 1 minus x squared plus c y. So this one called what? General solution. So we try to find particular solution with the initial condition, right? Just plug in 0, 0, which means we say with the space, so it will be 0, 0, 0. So it will be going to be 0, this is going to be 0, this is going to be 1. So 1 plus c will be 0, so c will be negative 1, right? So change the color again. So our final particular solution will be x inverse sine x plus square root 1 minus x squared minus 1. This particular solution. And the graph how it looks like, you grab a calculator, just plug in, right? So looks like that. Oh, let me erase this part. Hard to see that, right? So this one, erase it here. So looks like the graph using this particular solution. Okay. So using particular solution, we got the graph. Okay. All right. Thank you. See you later. Bye bye.